class. Today we're going to go over section 1.4, equations of lines. Our objectives today are to write equations of lines using the slope-intercept form and the point-slope form. We want to write equations of horizontal and vertical lines. We want to write equations of lines that are parallel or perpendicular to given lines. We want to find the average rate of change over an interval for nonlinear functions. Alright, so let's start out with the definition of the slope-intercept form of a line. Slope-intercept form of the equation of a line with slope m and y-intercept b is y equals mx plus b. In an applied context, m is the rate of change and b is the initial value when x equals 0. So let's look at an example. This one says an appliance repairman charges $60 for a service call plus $25 per hour for each hour spent on the repair. Assuming his service call charges can be modeled by a linear function of the number of hours spent on the repair, let's write the equation of the function. Okay, so let's break this down. We're going to let x represent the number of hours spent on the repair, and we're going to let y represent the service call charge. So that when we write this equation, we get y equals 25x plus $60. Keeping in mind that the $25 is the charge per hour, and x represents the number of hours spent on the repair, plus the initial $60 just to show up for the service call. So we have the $25 multiplied times the number of hours were there, plus the constant of $60 that's charged regardless of how long he's there, just to show up. Okay, let's look at the point-slope form of the equation of the line. The equation of the line with slope m that passes through a known point, x1, y1, is y minus y1 equals m times x minus x1. Alright, so the importance of the point-slope formula is that we're not always given the slope and the intercept. Sometimes we're given the slope and a point, or sometimes we're only given 2 points. We can find a slope and then use one of those points to find the equation of the line. So let's look at this example. This one says, let's write an equation for the line that passes through the point -1, 5 and has a slope of 3/4. Now it says by substituting the point slope form, we're going to obtain the following. Now let's keep in mind here that the point slope form was y minus y1 equals m times x minus x1. Okay. Now this is our x1. This is our y1. Okay, so all we're doing is substituting what we have here. Okay, y minus y1 is y minus 5, because our y1 here was 5, equals m, which is our slope, which was given in the problem, 3/4, times x minus x1. Now x1 is -1, so we wind up with minus -1. Now let's simplify this down and solve for y. Okay, this is the point slope form here. Simplified, it is y minus 5 equals 3/4 x plus 1, because minus a -1 is the same thing as plus 1. So this is the simplified point slope form. Okay. Now we're going to take that simplified point slope form and we're going to solve for y, so that if we need to use this equation, it'll be in slope-intercept form, which makes it easier to put into our TI calculator if we need to graph it or if we need to find solutions. Okay, so let's simplify it down from this point slope form down here to this slope-intercept form. Okay, so if we simplify it down, the first thing that we're going to do here is we're going to distribute that 3/4 to our parentheses. So we're going to distribute it to our x, we're going to distribute it to our 1 here. So 3/4 times x is 3/4 x, 3/4 times 1 is 3/4. That's where we get these. Okay, then we're going to solve for y by adding 5 to the other side. So essentially, we're adding 5 to 3/4. So when we simplify it, we get y equals 3/4 x plus 23/4. Okay, 23/4 came from 3/4 plus 5. Now you can calculate that on your own, or you can do it on the calculator. If you're doing it by hand, which we don't require you to do it by hand in this class, but if you're doing it by hand, you would find a common denominator, which is 4. Okay, second one already has a 4, so we don't have to worry about it. Remember, 4 times 5 is 20, so 5 is the same thing as 20/4, and that's where we get 23 over 4 as our b right here, which is our y-intercept. Okay, and that's an arrow, even though it's kind of an ugly arrow, just pointing to where that 23 over 4 goes. You can use your calculator to find that if you'd like. That's perfectly fine as well, because we allow you to use the TI-84 in this class. So we were given a point, we were given a slope, we found the point slope form, and we used the point slope form to simplify it down to the slope intercept form. Now, let's use 2 points to write the equation of a line. So we need to write an equation of the line that passes through the points -1, 5 and 2, 4. Okay, so first we need to find the slope, because regardless if we were doing it on slope intercept form or if we're doing it point slope form, either way we need the slope. So let's find the slope first. Change back to blue on my pen. Okay, in order to find the slope, we use the slope formula. Now keep in mind the slope formula is m equals y2 minus y1 over x2 minus x1. We already learned this, okay? Using the information we learned, moving forward to make it into a line. Okay, this is going to be my x1, this is going to be my y1, this is going to be my x2, this is my y2. Okay, so that's all they did to find the slope here. We plugged in y2, which is 4, minus y1, which is 5, and then we did x2, which is 2, minus x1, which is -1. So we have 2 minus a -1 on the bottom. 4 minus 5 is 1. 4 minus 5 is -1. 2 minus a -1 is +3. We wind up with -1/3. Okay, that's our slope. Okay, this is our slope. Remember, m is the same thing as slope. This is our slope. We have our slope. Now, if we want to use point slope, we can use either of these points that we want. We can use -1, 5, or we can use 2, 4. It doesn't matter which one you use. Okay, I'm going to use the first one. Okay, if you use the second one, it'll simplify down to the same line. Okay, but I'm going to use the first one here. So I'm going to put this in point slope form. Remember, point slope form is y minus y1 equals m times x minus x1. That's our point slope form, and that's all we're doing here. Y minus 5, because 5 is our y1, equals our slope, which is -1/3, times x minus x1, which is -1. This is our point slope form. Now let's simplify that down in the slope intercept form. First thing I'm going to do is simplify this. Minus a -1 is the same thing as +1. That's all we did in that first step. Okay, all we did was simplify that. In the second step, what we're going to do here is we're going to distribute the -1/3 to both these terms here. So we get y minus 5 equals -1/3 x minus 1/3. And then we're going to add 5 to the other side. And that's where they get y equals -1/3 x plus 14/3. Like I said, you can use your calculator to do the 5 minus 1/3, or you can calculate it by hand by converting your denominator here. Okay, this is prerequisite information you should already know. Oops, I tried to jump it up to a 15. I didn't even have to do it that hard. So common denominator here is going to be a 3. Okay, so this means that it's 15 over 3 minus 1/3, and that's where the 14/3 comes from. Like I said, you can do that calculation on your calculator, but there's how you do it by hand if you are interested. The same equation would have resulted if you had used the 0.24. Okay, it would have looked a little different to start with, and I'll show it to you real quick. Let's do it. Okay, so if you were to use the 0.24, then this would have been your x1, this would have been your y1. Okay, and we would have gone y minus y1 equals slope times x minus x1. Now the point slope forms would look different, but remember, if we simplify it down in the slope intercept, we should get the same answer. Okay, so let's see if we can simplify this down to slope intercept, see if we get the same thing. Okay, this is going to give me y minus 4 equals -1/3 x plus 2/3. Okay, all right, then I'm going to add 4 over to the other side. Okay, this should give me y equals -1/3 x. Now 2/3 plus 4 is the same thing as 2/3 plus 12/3. 2/3 plus 12/3 is 14/3. And you can see, hey, our slope-intercept forms are the same. So it doesn't matter which point you use, it will simplify down to the same thing in slope-intercept form if you do everything correctly. Oops. All right, another example. The Illinois Department of Corrections projects that the state prison population will grow at a constant rate from 2020 until 2025, with 48,000 inmates in 2020 and 52,000 projected in 2025. What is the rate of growth during this period? What do you think rate of growth is asking for? Rate of growth is another fancy way to ask for slope. Okay. Now if we look at this, we've got 48,000 inmates in 2020. Okay. And then 52,000 projected free in 2025. Now what we have to determine is which one of these is your X and which one is your Y. Okay. Now, the Y in this situation is going to be the thousands of inmates. The X is going to be the year. X is typically year. Okay. So if we're looking at this, then 48 is going to be your Y1. 2020 is going to be your X1. 52 is going to be your Y2. 2025 is going to be your X2. Okay. Now we simply use our slope formula. Remember, Y2 minus Y1 over X2 minus X1. Okay. That's where we get the formula that they have here. Okay. 52 minus 48, that's your Y2 minus your Y1, over 2025 minus 2022, or 2020, sorry. This is your X2 minus your X1. That simplifies down to 4/5. Or, if you write it as a decimal, 0.8. So the rate of growth is 0.8 thousand, or 800 prisoners per year. Okay? Simple enough. Just a slope, that's all they're asking for. Alright, keeping with that same question, part B says, write the equation that models the number n of prisoners in thousands during this period with x equal to the number of years. Okay, so we found the slope. We found that in our last problem. The slope was 0.8. That's what our slope is. Okay, I changed it up a little bit here. Instead of using a y, they use an n. They still use the x though. So this is essentially the same thing as the y was we were using in that last part to find the slope. Okay, so what we will do is we will technically do, to put it in point slope, we will do n minus n1 equals slope m times x minus x1. Okay, now this is going to be your n1, this is going to be your x1. And if you'd have used the other numbers, it still would have worked. If you'd have used your n2 and your x2, that would work and it would simplify down to the same thing in the slope-intercept form. But we're starting in point slope. So when they substitute this into point slope, which is what this equation is, we get n minus 48, which is our n1, equals 0.8 times x minus 2020, which is your x1. Then all we have to do is simplify this down into slope-intercept form. Okay. Now the way they did that is they distributed the 0.8 to both of these terms here. So we get n minus 48 equals 0.8x minus, what is this here? 2020 times 0.8. Do it on your calculator, see what you get. I'm getting 1616, so 1,616. And then all I have to do is add 48 to the other side to get n by itself. And what I'm getting is n equals 0.8x minus 1,568, which is the same thing they got for their slope-intercept. So, just because they use a different letter Don't let it freak you out. X and Y's are just letters, so we can turn them into other letters. We can turn them into N's. We can turn them into F's. We can turn them into Z's. Doesn't matter. It's just a letter. Still the same format for finding the slope and the equation. Now, let's use the function to estimate the prison population in 2030. So we just found this function. Let's see if we can execute this function to figure out what this population will be in 2030. Now, 2030 is a year, right? And remember, the years go in for our x, right? So we're taking our function that we just found, that n equals 0.8x minus 1,568, and we're substituting this year 2030 in for this x. Okay, so we've got n equals 0.8 times 2030 minus 1,568. If we do this calculation, we should get 56. Now, what is 56? Okay, this is where we've got to be a little careful here. What is 56? 56 is our n. Remember, our n represents the number of thousands of inmates. Okay, the number of thousands of inmates. So our answer isn't 56. Our answer is technically 56,000. Okay, so it's a little tricky there. Got to know your units that you're working with. Because if you just write 58, or if you type in 58 into your answer in MyMathLab, that's going to mark it wrong, because the answer is not 58 here. The prison population in Illinois is expected to be 58,000, because that's the units that they're in. So 58,000. Or sorry, I keep saying 58. The answer is 56, Mr. Shipes. 56,000 right there. Okay, just make sure you use the correct unit. 56,000. Now, let's look at something called vertical and horizontal lines and talk about them. Now, a vertical line has the form x equals a, where a is a constant and a is the x-coordinate of any point on that line. A horizontal line has the form y equals b, where b is a constant and b is the y-coordinate of any point on that line. Okay, so let's write the equations for the lines that pass through the point -1, 5 and have a slope of 0. Okay, if it has a slope of 0, is it a horizontal or a vertical line? And if it has a slope of undefined, is it a horizontal or vertical line? Now, I'm going to help you out right quick. If it has a slope of 0, it is a horizontal line. If it has an undefined slope, it's a vertical line. Okay. Now, if we use what we learned back here with our definitions, a vertical line has the form x equals a, where a is a constant and a is the x-coordinate of any point on the line. A horizontal line has the form y equals b, where b is a constant and b is the y-coordinate of any point on the line. Okay. If it has a slope of 0, it's a horizontal line. By the definition, the answer here for the actual equation of the line should be y equals b, where b is the y-coordinate. Let me underline it for you. The y-coordinate of any point on the line. Okay, so for this horizontal line with slope 0, okay, what we're going to have here is y equals, remember this is your x and this is your y, the y-coordinate of the line should turn out to be 5. Now you can be fancy here and you can put it in point slope if you'd like. Y minus 5 equals 0, which is your slope, times x minus x1, which is -1 here. And you can solve it out, but 0 times anything zeroes it out, and you basically wind up having y minus 5 equals 0. And if you solve for y, you get that y equals 5. But if you use the definition itself, it tells you that if you have a horizontal line, and a line with slope 0 is a horizontal line, that the answer is just the y-coordinate of any point on that line. Okay. Now, on the flip side, an undefined slope means it's a vertical line, which means that we can write the equation of that line by just the x-coordinate of that line. X equals -1. That's it. Easy enough. Don't overcomplicate it. Horizontal line, we use the y-coordinate. Y equals the y-coordinate. That is the equation of the horizontal line. Vertical line with undefined slope is just the x-coordinate of that line. X equals the x-coordinate is the equation of that line. Simple enough. Now, Here's where it gets a little more complicated. Parallel and perpendicular lines. Okay. Now, if asked to find a line parallel to another line, okay, if asked, find a line that is parallel to another line, this line is going to have the same slope as the original line. Okay, so if I have a kind of semi-draw a coordinate plane here, just for illustration purposes, this is your x-axis, this is your y-axis. Okay. Now, if I have an original line here, we'll say this is line y1, and I have a second line that is parallel to that line, that means that those lines never intersect. Okay, this is line y2. If y1 and y2 are parallel, they kind of look like this. You see how they're right beside each other, or they're next to each other, but they never run into each other. Those are parallel lines. As you could tell, they both go in the same direction, so they have the same slope. So keep that in mind. Parallel lines have the same slope. Okay, so if I give you the equation of the original line, like what they do here, if you find the slope of that original line, that slope is going to be same for the new line. If that slope is the same for the new line, then all you need is an additional point on that new line, and you can find the equation of that new line. That's the idea behind what we're about to do for parallel lines. Okay, so it says write the equation of the line through the point 4, 5 and parallel to the line 3x plus 2y equals -1. Step 1 is to find the slope of the original line. In order to find the slope of the original line here, we need to solve for y and put it in slope-intercept form. And that's what they do here. Okay, first thing they do is subtract 3x from both sides in order to solve for y. Okay, so that simplifies down to 2y equals -3x minus 1. Then they have to divide both sides by 2. Okay, keep in mind that that 2 goes to both the -3x and the -1. So it looks like y equals -3/2 x minus 1/2. Okay, this is the slope-intercept form of the original line. Okay, what we need from this is just the slope, because these lines are parallel, which means that this next new line is going to have the same slope. Okay, so what I'll do is I'll take this slope that we just found from the original line and I'll put it into the new line using the point slope form. Okay, so remember, point slope form is y minus y1 equals m times x minus x1. Okay, this will be the point slope form of the new line. Okay, we keep the same slope here. That's all they're doing here. Okay, remember, this is your x1, this is your y1. We keep the same slope that we just found here. We found that the slope was -3/2. Okay, we plug that in for the m here. So we get y minus y1, y1 was 5, equals m -3/2, because it's the same slope because it's parallel, times x minus x1, which is 4. Okay, this is the point slope form of your new line. Okay, we want to simplify that down into the slope-intercept form of your new line. prerequisite to the class is knowing how to simplify these forms, but we will walk through it real quick because this will be your answer. So I know some of you might struggle getting from the starred answer to your slope-intercept form, so let's see if we can solve it down. Now, I'll rewrite it over here. First thing we'll do is distribute the slope to both of those terms. We'll get y minus 5 equals negative 3 halves x plus, okay, I'll do it step by step. Negative 3 halves times negative 4 is positive 12 halves. 12 halves is the same thing as 6. Okay. Now all I have to do is add 5 to the other side. And that's where I get y equals negative 3 halves x plus 11, which is the slope-intercept form of the parallel line that runs through the point 4, 5. Okay, parallel lines. That's your example for parallel lines. Parallel lines have the same slope. So we find the slope of the original, we keep that slope, and then we use the point they gave us to put it in point-slope form for the new line and simplify that down to the slope-intercept form of the new line. Let's look at perpendicular next. Okay, now perpendicular lines have a negative reciprocal. A negative reciprocal slope. Okay, excuse my handwriting and my spelling. But they have a negative reciprocal slope. What that means is that I find the slope of the original line, I make it negative, and then I flip it. Okay. Now, it says write the equation of the line through 4, 5, and perpendicular to the line 3x plus 2y equals negative 1. Keep in mind that this is the same exact point and the same exact original equation that we worked with in the previous example. Okay. This is our x1, this is our y1. Now, we have already solved on the previous slide, we already solved this original equation to figure out its slope-intercept form, which is here. This is the slope-intercept form of this equation. And remember, all we're really concerned with here is the slope of this original equation. Okay. So, this line needs to not be parallel, it needs to be perpendicular. Like I said, that means it needs the negative reciprocal slope. Okay. That means we need to take negative 3 halves, which is the original slope, and we need to take the negative reciprocal of it. Okay, the negative of negative 3 halves is positive 3 halves. So our new m, let me change the color of it and everything. My new m here, negative of a negative is a positive, should be positive. And if I take the reciprocal of it, if I flip it, that should change it to 2/3. So this is the negative reciprocal slope. Okay, see how we changed the sign and flipped it. That's all we did. Negative reciprocal. Change the sign and flip. Change the sign and flip. That's all we're doing. Now we can take this new slope here, this negative reciprocal slope, and we can find the line that is perpendicular to the original line. Okay, so we take this slope, we put it in our point slope form. Remember, that's y minus y1 equals m times x minus x1. Okay, we put this new slope of 2/3 in for our m. We use our y1, which is 5, and we use our x1, which is 4. So we get y minus 5 equals 2/3 times x minus 4. Then they're going to simplify it from that point slope form to the slope intercept form. So remember, this is point slope. This is slope intercept. So this is our answer here. This is the slope-intercept form of the perpendicular line to the original equation, 3x plus 2y equals -1. Okay. Now I'm going to walk you through how we simplified here. So we took that y minus 5 equals 2/3 x minus 4. We distribute the 2/3 to both terms. We get y minus 5 equals 2/3 x. 2 times 4 is 8, so we get minus 8/3. I need to add 5 to the other side. This is going to give me y equals 2/3 x plus 7/3. If you have trouble computing the 5, let me get over here, the 5 minus 8/3 part for your constant, remember you need to find a common denominator. Okay, so oops, I've done that twice now. My dyslexia is kicking in just a hair. The 15 needs to go on top. 15 over 3 minus 8/3. 15 minus 8 is 7. Common denominator 3. Okay, this is our final answer. This is our perpendicular line to the original equation, 3x plus 2y equals -1, that goes through the point 4, 5. Just in case, okay, just in case you didn't know what perpendicular lines look like, I'm going to give you a little sketch here of what a perpendicular line looks like. Okay, I'll do it as best I can. So if your original line looks like this, this is your y1 line. A perpendicular line, y2, will intersect that line at a 90-degree angle, so that these lines intersect at a 90-degree angle on all fronts. So you have a perfect 90-degree angle from any side where this intersects. Okay, that's what a perpendicular line looks like. Okay, those are perpendicular lines. So you have to be able to find parallel lines, and you have to be able to find perpendicular lines. Probably one of the harder things that we do in this particular chapter. So let's look at some of these equations of lines that we've gone through so far. We have the general and standard form of the equation of the line. Typically, things are given in the general and standard form, and we make you solve it to either the point-slope form or the slope-intercept form. Okay, the general form of the equation of the line is ax plus by equals c, where a, b, and c are real numbers, and a, b are not both equal to 0. So this, in this previous question here, the form they gave it to you in, right here when we started, this is the general form of the equation of the line. Like I said, a lot of times we'll give it to you in general form and make you solve it to slope-intercept, just like we did here in the previous equation. Then you can work with a little bit better in slope-intercept form and find other stuff like parallel and perpendicular lines or points. Okay, so all the forms we have so far: the general or standard form, which is ax plus by equals c; the point-slope form, where you have y minus y1 equals m times x minus x1; the slope-intercept form, which is y equals mx plus b; the vertical line, which is x equals a; and the horizontal line, which is y equals b. Now, let's look at a new definition here: the average rate of change. Now, what is the average rate of change? I'll give you a hint. It's the same thing we've been doing almost the whole time. Slope. Okay, the average rate of change is the same thing as slope, and if you look at it, the forms are very, very similar. But let's look at the full definition here. The average rate of change of f of x with respect to x over the interval form from x equals a to x equals b, where a is less than b, is calculated as the average rate of change equals the change in f of x values over the corresponding change in x values, or f of b minus f of a equals b minus a. Notice I say that the average rate of change is essentially the same thing as slope, because if you notice, this formula looks really, really similar to y2 minus y1 over x2 minus x1. Okay, because f functions f of x or f of b or f of a can typically be written as y equals. If f equals a function, y can also equal that function. Okay, let's see how it comes into play here. This example says telecom artificial intelligence. The total worldwide software revenue for artificial intelligence used in telecommunication for the years 2016 and projected to 2025 is shown. The revenue can be modeled by the function r of t equals 170 t squared. Oops, got a slight typo in here. This t shouldn't be there, so I'm just going to white it out right here, or mark it out with my marker. So this should be the formula here. R of t equals 170 t squared minus 2,356 t plus 8,462, where t is the number of years after 2010 and r of t is in millions of dollars. A graph of r of t is shown. Okay, so we have the original bar graph here, and beside it we have a line representing that graph. Okay, now we want to find the average rate of change of r of t between 6 r of 6 and 15 r of 15. Now I'm going to take you back to the graph. Okay, and I'm going to write over here that we're looking for 6 r of 6 to 15 r of 15. Okay, that's what we're looking at. And I just want to graphically illustrate what we're looking for here. Now, we, in this first chapter, have been messing and learning with lines. Okay, if you notice, this graph here is not a line, it's a curve. Okay, but we're going to take the principle of what we've learned with lines and slope to estimate this average rate of change between 2 points on a curve. And it turns out that the slope between the 2 points you're looking for is the same thing as the average rate of change of this curved line. Okay, so if we look at this point 6 r of 6, I'm going to change colors so it won't mesh with the blue. It'll stand out a little bit more. This right here is the point 6 r of 6. Okay, if I go to 15, 15 is here. So 15 r of 15, oops, is here. Okay, if you notice, because this is a curved line, the slope changes a lot between this point 6 and this point 15. Okay, but if I were to take the slope of every point between 6 and 15 here and average them, the average would turn out to be the same as the slope of the line that connects, the straight line that connects those 2 points. And forgive me, because I am not the best line drawer, but I'm doing the best I can. See if I can do it just a little bit better. Well, I think that's actually worse. That is actually much worse. But the straight line that connects both of those points, we'll try it one more time, hope for the best. Okay, but the straight line that connects both of these points, okay, the slope of it is the same thing as the average rate of change of this entire curve between those 2 points. Alright, so conceptually we know what this is now. Now we just have to find it. Okay, so here's what we have to do. Alright, it jumps real simple for you. It says r of 15 minus r of 6 equals 15 minus 6. What they're doing there is putting it in that average rate of change formula. Okay, that's all they're doing there. Okay, essentially it's just y2 minus y1 over x2 minus x1, which is your slope formula. They're officially calling it f of b minus f of a over b minus a. Okay, where f of b is r of 15, f of a is r of 6. Your b is 15, your a is 6. I think we can all see that 15 minus 6 gives us 9. I'm not so much worried about that part. The r of 15 and the r of 6, I want to make sure you know how to calculate those. So I'm going to go back to the previous slide here. And we're going to calculate r of 6 and r of 15. Okay. R of 6 is found by putting 6 into this equation. So it'll be 170 times 6 squared minus 2,356 times 6 plus 8,462. Okay? Use your calculator to simplify that. I'm not going to sit here and simplify it for you. Use your calculator to simplify that. If you do, that's where that 11,372 comes from. Okay. Now, when they find R of 15, it's very similar to what we did there. Okay, all we're doing is taking the equation and we're plugging 15 in for t. So it's 170 times 15 squared minus 2,356 times 15 plus 8,462. Okay, and when they plug that in, we get 446. Okay, that's how R of 6 and R of 15 are found. Like I said, use your calculator to simplify those equations. That's why we have it. Now, we put it into that form. Like I said, 15 minus 6 is 9. 11,372 minus 446 divided by 9. Use your calculator. Simplify it. Gives you 1,214. This is your answer. This is your average rate of change between those 2 points, 6 R of 6 and 15 R of 15. If we go to interpret this answer for part B in the context of our question here, it could be interpreted as following. One possible interpretation is that the worldwide software revenue for artificial intelligence used in telecommunications is projected to increase by an average of 1,214 million per year during the period from 2016 to 2025. Okay, let's do one more. The average velocity. Suppose a ball is shot straight upward at 64 feet per second. The equation that gives the height of the ball t seconds after it is shot is f of t equals 64t minus 16t squared. Let's find the average velocity, or the average rate of change, of the height per second of the ball over the time interval from t equals 1 to t equals 2. Okay. Average velocity, average rate of change. What are we looking for here? We're just looking for the slope. Okay. Just a different way to ask for the slope. Alright, so how are we going to do this? Well, we have the equation here. Okay, this equation that they rewrote on the other page here is just the equation from the actual question itself, the 64t minus 16t squared. Okay, we want to look at it over that time interval from t equals 1 to t equals 2. So if I write this as f of b minus f of a over b minus a, or you can use your slope formula if you want to, y2 minus y1 over x2 minus x1. That's fine. Our b is going to be 2. Our a is going to be 1, which means we need to find what f of 2 is, and we need to find what f of 1 is, because we're going to be subtracting those two terms. Okay, so they've already kind of worked it out for you there. Oops. Let me jump here and show you how they found it. Okay, f of 2, all I had to do is take my equation, plug 2 in for t. Okay, we can use our calculator to simplify this down. And I might not have done the best job here, so I'm going to rewrite this. This is a squared, not a multiplication. Just don't want to be unclear. You can see it from the equation, but like I said, just wanted to make it clear in my writing. Okay, they did the same thing for f of 1. They just plugged 1 in for t. Okay, you can use your calculator to simplify that down. Okay, 64 times 2 is 128. Okay, 2 squared is 4. 16 times 4 is 64. So, yeah. So we wind up with 128 minus 64. That's where they got this term right here. Okay. Now that also simplifies down into just 64. 64 times 1 is 64. 1 squared is 1 times 16 is 16. That's where they got this point right here. This is your f of 1. Okay, 64 minus 16 is just 48. So essentially what they're doing here is they have 64 minus 48 over 2 minus 1. Well, 64 minus 48 is 16. 2 minus 1 is 1. I wind up with 16 over 1, which is 16, which is your 16 feet per second. That is your average velocity from time 1 second to time 2 seconds. Okay, just your slope between those 2 points. That's all it is. Find your f of 2, find your f of 1, plug it in this formula, f of b minus f of a over b minus a, which is essentially just your slope formula in different letters. That's all we're doing right here and simplifying it down. Okay, that's all we're doing. Don't make it any more complicated than it has to be. If you have any questions, send me an email, let me know. Other than that, keep working on your homework, quizzes, whatever else is available, and I will see y'all next lecture.